Welcome to Circuit Talk Funders and Founders. I'm John Cole, Senior Manager on the Semiconductor team at MITRE Ingenuity. We are a nonprofit dedicated to solving problems for a safer world. Our semiconductor team is hard at work meeting the nation's challenges around semiconductor breakthrough technologies and the CHIPS Act. Circuit Talk Funders and Founders is part of MITRE's Circuit Talk podcast and video series, and it elevates the revolutionary, disruptive work being done by semiconductor entrepreneurs and investors. This is an exciting time to be working with semiconductor startups. The nation is waking up to just how critical they are to our national and economic security. Today, I'm joined on Funders and Founders by Asif Bhatti, the head of strategy and innovation at America's Frontier Fund. Asif leads investing diligence across the organization's startup investment portfolios, and he leverages his background in strategy, technology, and advanced analytics to do that. He earned his Bachelor of Science in Biomedical Engineering and in Chemistry at the University of Illinois, and an MS in Data Science and Public Policy at Georgetown University here in DC. Before joining AFF as a founding team member, he had a career that spanned consulting and government, which included time at McKinsey and supporting the Biden-Harris transition. So today on Funders and Founders, Asif and I will be discussing his experiences and insights at the intersection of technology, innovation, and investment and policy. So I'm excited to hear Asif's thoughts on the future of frontier technologies and how venture capital is this crucial part of defending our nation. So welcome, Asif. It's great to have you here.
It's a pleasure. Thanks, John.
Maybe you can start by just giving us the 30,000 foot view of America's Frontier Fund, or do you go by AFF? Is that comfortable?
AFF.
How did you get started and what are you investing in?
So admittedly, I think if we go to the problems that AFF is solving, it's trying to provide the crucial unlock and kind of invigoration to the hard tech or deep tech innovation economy that has historically been underinvested in. And if I take a quick step back, there's fundamentally the past 3 decades or 4 decades have been an incredible opportunity of growth that venture capital and the private markets have driven through investment in technology, but that particularly focused on software. And for AFF, I think our founding team recognized an underpinning of core deep tech sectors that will likely and assuredly develop the next set of sectors and economies that we'll see in the next 50 years. And so those could be microelectronics, those could be AI, quantum, advanced manufacturing, 5G, 6G, synthetic bio, new materials. All of these are hard sciences that ultimately require decades to kind of research, incubate, and then commercialize. And so AFF is an organization mission focused to ensuring the United States and the Western allied world has a leadership position or has an ability to take the best thinkers, the best entrepreneurs, the best innovators, and allow them to grow those technical areas into commercial business and startups and help ensure that economic leadership benefits as many people as possible across not only the United States, but the world. And so if we look at microelectronics and semiconductors, it's just one area. The foundation of that sector becomes instrumental in fueling every other deep tech area. So AFF really is a 3-component organization. One is our deep technical expertise, the science and technology team that incorporates former DARPA PMs, lead engineers from manufacturing organizations. It's the brains of much of what we end up finding as important sectors for investing in. The other 2 components, and I'll double and click into these as well, is our venture studios that help build businesses from the ground up, from the inception of the idea all the way up to funding and continuing its growth. And then the last thing, of course, is our fund. If I click into our first one, the technical expertise, our chairman, Sam Palmisano, was from IBM, and they did a great thing there called backcasting, which we now have kind of repurposed in our way of frontier casting and looking at what is the potential future that a sector might have. And admittedly, it may not be right, but through the experiences of our team members, inclusive of our board, they were right for certain sectors that they knew of 10 years ahead of time, but unfortunately may or may not have acted on that. One example of that is cloud technology, right? And so when you start to see, if you start to articulate some of those futures and then build nodes towards what might be the incremental or significant leapfrog innovation, tracking towards it and continuously measuring it can be helpful towards ensuring that that growth, that innovation happens in a way that it's actually benefiting a collective good or a collective group of people. The venture studios then become, hey, like we are recognizing this is a incredibly important node or incredibly important innovation. And the scientist, this innovator is doing a great job. We need to try to see if we can bring all the right people, all the right team members around it from across the coast, wherever in the United States, and ensure that initial team, that entrepreneur set of people, can actually quickly accelerate the commercialization and growth of that into a sector or a particular technology area. And then, of course, the venture studio would come to a level where it's a proof of concept, because some of these technology areas are they take a while. But at the proof of concept level, enough such that then private funds like ours, Frontier Fund One, which is a $500 million fund, or others would look to invest in some of those companies as well. And it's not one-to-one where an idea from Venture Studio goes to Frontier Fund One, but it is to say that if you can start to elevate some ideas, those ideas on their own can go fundraise as they might, and Frontier Fund One can also perhaps participate or otherwise invest in companies already existing in the innovation ecosystem across the US and across the world in the respective sectors of microelectronics, AI, quantum, etc.
So you mentioned a number of technologies, everything from sort of 6G to SynBio in there. Where are you guys starting?
Yeah, so I think perhaps this is a little bit intuitive, or maybe it's already said for, but semiconductors are already what a lot of folks are starting to think about. And that the reason I think they're doing that is the recognition that a lot of the investments made in this specific industry and sector will be foundational to all the other deep tech areas as well. Hence, perhaps why there's federal funding kind of being put to increase the innovation activity, the capacity of the United States as well. But I think that becomes a first and foremost area that we become incredibly excited about. Even more so, a point of strength for us here in the US is the design capability and the IP that's created in the microelectronics space. And there's a lot of opportunity in terms of the innovation that can happen there that ultimately may not have happened because of the continued shrinking of chips and not necessarily needing to adjust the tools or the solutions that help grow that as well.
So you've got this flywheel, 3 components where you've got subject matter experts, you've got a fund, and you also have the incubator. It sounds like the model.
Venture Studio.
Venture Studio. Well, maybe we can just flow into that. I just said incubator, you said Venture Studio. What's the difference, and what's AFF trying to do differently there?
Really, I think Venture Studios, or let's go with accelerators and incubators. They do a great job of providing all the side support that's needed for a business to incubate, to grow. And that works incredibly well for software or startups that have fast cycles of learning, frankly, anything less than 5 years, right? But with Venture Studios, it's for entrepreneurial endeavors that really it's a long time that you get to the level where it's the same revenue milestone or the same funding milestone that other traditional startups that go through incubator accelerators. So the core distinction there is that Venture Studios co-build the innovation there. And our team at Roadrunner identifies some of the ideas. We also solicit some of the ideas that might be coming, but really we are co-building that startup, that initial team, by bringing in not only our folks, but then other resident entrepreneurs or scientists or CEOs that, at least from a VC standpoint, it is always the team that leads to the success of that idea, right? And so if you have the right idea, Venture Studios and Roadrunner Studios would build that initial team and then continue to shepherd it to the point where then it is kind of on its own trekking forward. The distinction there being, I think, at its core element, the co-building point.
Well, we certainly talked a lot about that with semiconductor startups here in the sense that it takes a wide variety of skill sets to get it going. And there's, in addition to the business risk that you see on almost any startup, you also have a enormous technical risk because you're starting maybe from the lab scale. You've got the commercialization and the prove out of the technology along the way. So that sounds like, the companies that you would be interacting with, you take a lot more touch and support. So we talked about sort of diving into Roadrunner Studios as the solution, the chasm that startups face when they're sort of moving from R&D over all the way to commercialization. What gap is Roadrunners fulfilling there? Like, what are you bringing together?
Yeah, so I think there's a double chasm there. One is, of course, on the funding side, which we already aware of, but the other side is also the linking of R&D to commercialization as well. And it's historically, if I go back to where many of these industries that we are now participating in, both the e-commerce industry, the semiconductors, they were all a function of one, government investment that was made to help catalyze some of them. An example on space, of course, NASA and the great work that was done there. But then that government investment led to kind of a corporate research engine that started to develop. And so you think of, this is preceding me, but this is like Park Xerox, Bell Labs, IBM, all of these organizations had fantastic corporate research labs that unfortunately over now many years has withered away just as function of the orientation towards perhaps a shorter cycle of learning, right? And so those corporate labs were that link between R&D and commercialization. And so if I think about, as an example, Bell Labs and John Bardeen, I'm sure this is a story that many have already shared on your podcast before, but it was there where he founded the transistor at Bell Labs, and then Bell Labs commercialized it into a phone telecommunications application, not knowing, of course, the larger implication of a whole industry being birthed. But nonetheless, the benefit of that was that there's a fundamental technology that had a very quick near-term commercial application and provided the fuel enough for it then to grow and expand into now the whole industry that we are participating in. And in absence of those labs, that's where you have to start. There's a call to action to close that chasm. And so in our engagement in New Mexico, as one example, that's where Roadrunner Studios will be headquartered in the next few months, actually. And there's a ton of federal funding that goes into organizations like AFRL, Sandia National Labs, in Los Alamos. There's a ton of that goes on there, and the ideation is there. It's just untapped. And when you start to tap into it and build near-term commercial use cases, I don't think you or I could even contemplate the potential opportunities that come of it, because we wouldn't know until you actually start to take some of those ideas out of lab into commercial startups. Even if it's like a simple application, it can open up the door in ways that then completely shift the way that industries or economies even work. And so that's really what Roadrunner starts to do, is help close that gap from lab into commercialization, making sure that one, ideas map to what perhaps the near-term market need is, but then two, more importantly, going back to the first point, is all the right people, the right entrepreneurs, startups, CEOs are there, and they're brought in from across the United States to those regions, to those areas where those ideas are happening.
So you're bringing together a number of people to make this happen. One of the challenges that we see in the semiconductor industry is you've very technical space. Oftentimes, the new venture starts with the seed of technology. You've got a technical entrepreneur. Oftentimes, it's hard, or one of the challenges is someone who's really great at sort of dreaming something up in the lab and implementing it on an engineering scale doesn't have the right skill set to take it, through the business cycle and commercialization and drive that. How do you, when you look at a technology coming out, you may find that the researcher or the PI doesn't really have those skills. How do you kind of approach that? What do you do to?
Yeah, I mean, admittedly, some PIs and researchers absolutely have the skills, sure, and they have the appetite as well. But yeah, I would also just say that a lot of them just don't, right? They don't want to necessarily do it, or there isn't that line of sight to the benefit of it. And so I would argue that there's a whole slew of scientists and researchers that don't even may have not even tasted the opportunity that lies in front of them, because it's just our pathways to commercialization across our research institutions aren't necessarily there, or as well oiled perhaps as they could be. And so I have a core belief that if you're dedicating your life to a core technical area, that it is very service oriented in many ways, because that innovation that they're driving towards has some end benefit to a group of people or particular tech sector area. There's a passion that comes with it. It's just ensuring that the right pathways are there for those scientists and researchers who are dedicating their lives to recognize that, hey, there is a way to actually make this demonstrably changing the way the world works or lives, right? And improving the outcomes of our community members or whoever it might be. But I'd say that's one, but maybe targeted to your question even more so. There are ways to work with founders, technical founders as well, that allows them to still kind of explore the depths of the science while pairing up the right complementary person who could be more, say, business or entrepreneurially oriented. And so in building those teams at Roadrunner, you start to actually allow for, one, the continued exploration of the frontiers of science, as Dr. Vanvar Bush put it, but also take some of that great thinking and build business or build startups around it as well. And that comes down to the team ultimately.
Yeah, that's super important work, right? Like you said, some researchers may want to stay in the lab, and some may actually have, you know, all the tool set and the flair to just kind of go after the entrepreneurial opportunities. But I sort of, on a similar note, you know, you've got SBIR grants have long been sort of like that financial bridge, maybe, and there also other government programs right now, like I-Corps, for example, also do a little bit of the sort of customer discovery and helping technical founders get out of the lab and get in front of potential customers. What's different, or how does this kind of complement those kinds of programs right now?
Yeah, so SBIR and a lot of the grant fundings, they provide grant funding, but some of the other resources or frankly, the ability to say, okay, we'll help you bring the right people in or connect you to this, that becomes a little void in some of those programs. I think the difference here ultimately then is that there is a portion of at Roadrunner Venture Studios that will be an amount of dollars given to those ideas so that they can build teams and attract talent. But it's even more important for the Roadrunner team itself, outside of the portfolio company there, to actually ensure that every element of that, from technical to business, is actually being met through their time at the venture studio. And that is culpability that the studio takes in actually in making sure that startup gets to a level of a proof of concept. Again, goal being that proof of concept can go get all of our venture capital friends to feel like, hey, yeah, this is something we could put money behind, right? So whatever it takes, that the venture studios eventually, or our venture studios strive to ensure that point of success, that milestone of proof of concept, is there enough that then we ensure that startup is on its road.
Yeah, that's really crucial to get that initial traction and get on the path to commercial viability. But you mentioned Roadrunners in New Mexico. That doesn't sound like your traditional technology hub, and it sounds like you expect the majority of the next wave of frontier tech to come from some of these unlikely places. Traditional tech hubs are New York and Boston and the Bay Area, but they may not be the source of frontier tech, it sounds like. Where is that trend coming from, and where, you know, literally on the map, are you looking for new technologies to come from?
Yeah, so I think we think of the 5 coastal cities as the ones that are fueling the innovation and the greatest thinking. But admittedly, I think we all realize this. There's an underlying current of ideas happen somewhere and then they migrate over there. Yep. And the migration is probably perhaps part of the second chasm that we were talking about. But going back, it's never been the case that waves of innovation only happen there. I think I'll use John Bardeen as another example. I consider Chicago home. And Wisconsin, University of Wisconsin, was where John Bardeen went to school, both undergraduate and graduate, and that's where that ideation started to happen. The thing that birthed the transistor, and ultimately it was a function of having to go to a corporate lab or a coastal city to kind of help commercialize it. But that isn't to neglect the fact that the initial investments that were made by, say, those universities in the Midwest, in the heartland, in the South were theirs to kind of not only cultivate the individual, but then also ensure that all the other lab space or services to kind of explore curiously was available for John Bardeen or any other researcher for that matter, or an entrepreneur. It is, I think, we at AFF fundamentally start to see this even more apparent through our own machine platform called Neo, where we're looking at the innovation activity happening across all these institutions, whether it's as straightforward as patent filings to as complex as authorship networks and how kind of various nodes are interacting or various authors are interacting with each other, because research may not just be concentrated to singular institutions, but across a network of institutions. And so once you start to see that, it actually shows you that, hey, it's really cool in that there's great ideas across all of these technology areas happening across the United States. Now, what can you do to help accelerate the commercialization versus having those individuals have to pick up their families and move out to the coastal cities and find dollars? How about we bring the dollars over to them? And how about we bring the team members that they might need also to them? Which is going back to the point of Roadrunner, where ultimately innovation's happening in New Mexico. You see it with the federally funded labs there and the research institutions there as well. It's how you tap into it and bring all the necessary resources that everybody to date has gone to the coastal cities for. And it is not to say that we shouldn't continue to do that, but I think there's an opportunity to we need to act fast in actually commercializing some of these technology areas, because things are moving much faster than they previously have as well. And so getting people to move is much harder. I think if you bring things to them and make it easier for them to act on their idea or their startup, becomes incredibly valuable asset and a speed to the problem that collectively we're facing in the United States.
So I like that idea. If you were to say that ideas are sort of the new oil of the developing economy, they can kind of come from anywhere, anyone within the country, but we're sort of moving the machinery to take those and build companies out of them to them wherever they may be, rather than dragging them out to the coast or just denying them the opportunity. That's interesting.
And one of AFF's goals is to shine a light on those ideas and opportunities and kind of signal to the market, the government, philanthropy that, hey, there's legitimate businesses here.
Yeah. Sort of putting on your public policy hat while we're talking about coastal cities, focus of Silicon Valley for the past 2 decades has just been shifting more and more to software. Meanwhile, over the last few years, at least, the US government has kind of woken up to a perceived threat, right? So here's the public policy part. The government's now pouring trillions of dollars into hardware, not just the CHIPS Act, but there are a lot of government initiatives that are starting up that are focused on some of the technologies you mentioned, and then sort of the hardware technology development. What happened there, and why is that shift happening?
Yeah, so maybe if I understand your question, one is like, why is Silicon Valley operated in the way, or rather, not just Silicon Valley, not to point out, but the larger private markets operated in the way that they have towards software startups and ideas, and then separately the change in kind of industrial policy that might be as a function of the 2.2 or 2 trillion plus dollars that is coming as part of investment from the federal government.
A part of it's industrial policy, and some of it is defense policy, right? It's looking at the sort of the strategic lay of the land and how that's changing, and how these technologies may be underpinning our future defense. Yeah,
I mean, so I'll say that maybe on the first point of the private markets and their orientation, I think the orientation towards 4-year cycles and near-term returns and break things fast and learn has been great for software startups. It works well. It's a model that works incredibly well, because then you learn and you can, very low cost in trying to pivot, as most of Silicon Valley would say. Yeah, break things, learn, pivot. it's harder for hard tech. You can't do that because there's investments that both in time, resources, and research that come that if you spent like a decade doing something, you're not going to pivot for another decade, right? That's tough. And so I think the investment or the private markets orientation towards that software probably has been driven a lot by that, and also the opportunity. Frankly, private markets act when there's opportunity, and like free markets can reign in those technology areas, which has been ultimately true for the emergence of many of the commercial businesses and technology businesses that we see, whether it's anywhere from Google all the way down to Facebook and e-commerce, social media, and the emergences of those. And I think maybe on the second question that you were pointing to, the investment that is coming from this administration is one that actually I think is similar to the investments we made way back when those corporate labs were around. And in making those investments, I think it's less to do about defense, really. It's more to do about competitive leadership. And I think defense folks think about conflict and challenges that are geopolitical. I ultimately don't think that the challenge is that as much as it is we have just perhaps lost our ability to be leaders in some of the sectors, and we are in the United States and in the large parts of the world the foremost thinkers on some of these sectors, the most creative thinkers in technology sectors or new emerging sectors, and that thinking still happens today. It's just that we aren't doing anything about how that creativity is actually commercialized, and other countries across the world are doing something about the great creativity that is in the United States. And I think you and I were talking about this maybe a few months ago, but semiconductors is one example. 54% or 50+% of the entrepreneurs in semiconductor industries in East Asia were educated in the United States. And you think about that, right? I go back to my John Bardeen example. He was educated in Wisconsin, but who's reaping the benefit of Silicon Valley semiconductor industry? It's not Wisconsin, it's Silicon Valley. And then that's the same case for these other sectors where the creativity and the genius behind all of this is happening all across the higher education institutions, the research institutions, and the engine in the United States. It's a matter of how do you actually start to compete and allow for leadership where it matters, and that means in terms of economic leadership. That is, I think, also where a lot of now the federal funding, the philanthropic funding, and the private funding are trying to meet this problem. I'll give you the example of, you probably saw the announcement of CZI, Chan Zuckerberg Institute, making an investment into the BioHub in Chicago, right? You're starting to see a convergence of what I'll call three sources of capital: private, philanthropic, and public, being braided together to drive leadership in technology areas that exist in idea already across the United States. And it's a moment in time where those who take a magnifying glass or a microscope can actually go find them and actually create incredible opportunity for those places, those economies, and those people. I don't know if I got to the last question, but I think it really becomes about economic leadership more than anything.
No, you did. I mean, so that's a interesting point of view there, right? So it's more about the economy than it is about, say, defense or strategy or intelligence or anything else. As we
maybe I'll just add, they're not decoupled. Like, I think we think about them as decoupled. The National Security Commission for Artificial Intelligence articulated the importance of artificial intelligence and semiconductors, but then also recognized, hey, it's not a separate issue from economic leadership. Those two are together.
Yeah, that makes sense. So tying that all back to sort of semiconductors for the moment, it's a pretty bipartisan issue, right? So this administration, the previous administration, all recognized that innovation in semiconductors is sort of crucial for strategy, for national security, for economic development. What needs to change in the ecosystem to sort of make semiconductors the destination for VC money?
Yeah. So I think what needs to change is perhaps the investor mindset is one. Number two is a de-risking of some of the technologies and compression of the cycles of learning in these sectors.
Mhm.
And then number three would be a keen focus on where that innovation is happening and identifying it early.
I was thinking of like actually, so I mean, AFF is focused. You have a number of technical, very technical folks that are there, right, to help make smart decisions about some of these technology companies. Which,
Yeah,
from my discussions, I think that's one of the things that's held VC back a little bit. Become very sort of Wall Street oriented, in the sense that a lot of folks in the industry now have a financial background rather than a technical background. Whereas if you rewind back to the early days of the 50s and 60s, they were all semiconductor entrepreneurs, and so that's what they were focused. But they were also technically confident enough to sort of cut those deals on their own. And now it takes a team, and it takes folks on that team with real technical depth that can tell the difference between just an extended postdoc project, right, and could actually be a company. And
no, I think that's right. So I just was jotting down. I think the three things that would be helpful for attracting more capital is one, a mindset shift in terms of how VC is approaching these technical areas. You started to articulate some of that earlier. Two is the de-risking of the technology and compressing the cycles of learning, which we're already starting to see in a lot of these deep tech areas. And then three is the identification of them earlier on, just to be able to drive VC investment, because sometimes it goes under the radar, and then VC may not be able to participate in it. But the mindset shift, as I pointed, is really, I think, historically there were technical or technically competent or technically well-read individuals that were also making investment decisions, and that has slowly evolved over time to just have an orientation towards just financial return purely and the measurement of that return. And with these sectors, investors can look at now how they can bring technical competence into developing a risk reward model that isn't necessarily a 2 or 3 or 4 year thing, but maybe 5, 6, 7 year thing. And that shift in mindset, once that happens, at least for AFF, in part with the set of folks and the team members we have on our technical team, as well as our investor team, the hand-in-hand nature of that actually enables a powerful investor mindset and actually being able to bring capital to bear. Then the second point around de-risking, we're starting to see that already. So a couple of ways technologies and sectors get de-risked is, of course, the signals that come from government investment, as we see with semiconductors. A lot of people are now starting to get excited about it. Secondarily, philanthropic capital also does a great job in terms of signaling technology areas or sectors that are of interest. And then subsequently, I think AFF, in part of what we will start to do as well with our investment, will become a signal as well, perhaps, to helping identify de-risked technology that may still have a longer horizon, but at least there's a line of sight, both from the technical vision and the business vision, that for other investors who may not have the full depth of a technical team like we do at AFF, to be able to participate in that investment or in that economy as well. And then the last point that I mentioned was the identification of the ideas. I think early identification of innovation across the US and across the research engine can be incredibly important, because we are finding already that things and sectors are moving much faster in terms of their maturation. The AI Commission, as an example, thought a lot of what we were going to see with AI was a handful of years out from now, but it's here now. And so I think investors can start to also spend more time identifying innovation earlier, and recognize that those timelines traditionally, where we thought it takes 10 years or this will happen, that will happen, it's going to compress even more, just as a function of how technologies collectively are converging, including artificial intelligence and what we have in this moment in time.
Yeah. So when you talk about compressing, though, too, my mind automatically goes to just compressing the de-risking cycles too, in terms of technology, right? So the barrier often to investing in a technical deal is the additional technical risk. And if you can't quickly de-risk it, your money's going to be sitting there at risk, and it's hard to get people to come in and invest in your idea. Things that are coming down the line there, right? So rapid prototyping, more accessible in the US, different ways, the high mix, low volume opportunity, digital twins, right? Seeing some of these come out, do you think that those are going to change sort of the economics of the game, or the economics of investing in these deals?
I think in semiconductors, as an example, design automation has an incredible opportunity in the United States to actually help perpetuate that compression in learning, right? So if we're right now design EDA, chip design takes years and hundreds of people, can we shrink it down to months or weeks to single sets of people, right?
Yeah.
And that's very possible with AI compression, parallelization of compute, re-architecting the tooling such that it actually is compressing some of the physical data back and forth that comes between various functional verification and physical verification steps. And even more, as you just mentioned, if you can start to design some of those chips in ways that you actually have a digital twin for the manufacturing process, you might even be able to compress the timeline and actually shifting from design to MPWs out to scaled manufacturing as well. And so, yes, I think absolutely in terms of compression, both in time, but compression in terms of de-risking will happen as a function of just the way that technology will now help enable in semiconductors, low mix, high volume manufacturing, or digital twins of manufacturing lines to be able to then create novel ASICs, or on the design side, provide the level of support that a ChatGPT might provide me right now on chip design, where it's like, okay, hey, I need a chip for a cardiovascular device that's going to be embedded within a biological system, and you provided all these like human readable constraints, and it proposes back to you perhaps an initial option or design. That is a world where we can actually start to then very much shrink a lot of those design cycles on the chip side, but you can articulate that out to other sectors as well.
Yeah, that sounds like an enormous amount of computing power and innovation to get there, but that the concept of being able to talk your way through designing a chip would be really interesting, and just open up to so many more ideas and so many more creators kind of getting out there, not just limited to maybe even to engineers. But so in our conversation, you've talked a little bit about different platforms that AFF is building for to build their investment platform on top of, say, data platforms, I think, right? So you talked a little bit about FrontierCast. I think Neo was another system that you briefly talked about. But I understand to sort of be a leader and to sort of turn over or sort of challenge the industry and what folks are doing right now, you come with some data-driven tools. What are you doing there?
Yeah, I think that those two things hit to a core learning that perhaps our collective team has found. FrontierCast is never going to be perfect or right, but it's going to help articulate the art of possible. We're a shared vision, which it's not just important for AFF, but in turn, our partnerships across the industry, including semiconductors, it becomes important to be able to say, hey, this is potentially where we could go. And if there's alignment, which we are finding at least on the semiconductor side with one of our semiconductor visions, then you get a whole group of people organized around something that's very, very clear and has a line of sight. And that FrontierCast becomes a very powerful kind of guideposts to how investments can be made, or at least progress towards something can be made. On Neo, so my background is I'm a technologist at heart, and so information and being part of the information age now is always overwhelming, but when distilled into now core insights, we can AFF as investors can identify pretty significant alpha earlier on in terms of in terms of identifying ideas that are tracking towards, say, a specific frontier-casted vision. And the Neo platform, and it's called Nonlinear Economic Outcomes, actually drives a lot of incredible insights from proprietary data sets that we've built and enriched through whatever is publicly available and privately available, and ensure that we then start to identify great, perhaps even topical areas of innovations that might be important. I'll give you one example. A technology that's existed for quite some time, additive manufacturing. It's not necessarily novel or new, but with the advent of now additive manufacturing and 3D printing, you can get at scale engines being printed, or manufacturing of entire systems that you previously had to deconstruct into components. Yeah. And with that now, there's a slew of startups that I've spoken to and started to look at as well that are building incredible material strength and efficiency in production and reusability that would not have been seen given previously in 20 years when additive manufacturing was present and found without the combination of 3D printing technology. And so you start, at least with Neo and FrontierCast, it's both not only visions and startups, but it also how technologies and engineering breakthroughs or scientific breakthroughs can intersect and combine to create great startups and great investment opportunities.
Yeah, that's a hard thing to look into the future and see, right? You can anybody can kind of look at the components, but it's hard to put them together. So is that what the software does? It looks at disparate technologies or neglected technologies, or how do you do that?
Yeah, it's a tool that looks at the whole kind of innovation base that exists and how those innovations are either driving through authorship networks, through even just patents, but also seeing that if there's early buddings of the intersection of two technology areas that might be important. An easy example that is known as like the intersection of chip design with synthetic bio, right? And can you intersect those two technology areas? You can see the connective tissue of certain networks become increasingly powerful as certain innovation activity or patent activity or research activity or grant activity, whatever, starts to build more and more and more. And then once that connective tissue is there, you're like, okay, there's a muscle there, there's something there. So let's actually go double click into this as a technical area.
That's great. Fantastic. Well, Asif, it was great having you on Funders and Founders. Thanks for coming, talking about all the great work that AFF is doing within the ecosystem and for American innovation. Hope to talk to you again soon. Thanks.
Absolutely. Thanks.